from Quantum Motorworks, doing another tutorial for you guys today. Right here we have a 1995 Harley Davidson Sportster 1200, and the customer wants us to go ahead and relocate the forward hand control switches to a lower portion of the bike where it looks cool and eliminates the wiring from the midsection all the way up to the front, so we won't have any wires here. Before we go ahead and jump into this, there's a couple things you guys need to know as far as choosing the correct electrical components, since all of this work here is going to be custom and there really is no service manual or way to go about it. You kind of just got to understand Harley Davidson electrical systems and how to modify them in basic electrical theory. So we're going to go ahead and jump into that in a later video right after we do this one here. But first we're going to go ahead and show you how to wire up, how to first choose the correct relays and switches for your custom wiring system, and then basically how to wire it up on a a test stand or on a table and make sure everything works, and then you can apply those principles to your actual bike and so forth, and we'll go ahead and get to that in a later video like I said. So go ahead and stay tuned. If you're not following me, go ahead and follow right now and like this video so you can save it for later. There's a lot of key points that we're going to go ahead and mention here, and thank you for watching.
Okay guys, so what we have in front of us here is a 1995 Harley Davidson Sportster 1200, and as we said in the intro, we're going to be relocating the switches here. You can see we have the engine start stop, runs, engine stop run, the start switch. We're going to be eliminating the turn signal switches. Customer doesn't want turn signals on the bike. We're going to be eliminating the left turn signal, no horn, and we're going to be doing a custom low beam high beam switch on a switch panel. Okay guys, now before we jump into this, you got to have a little bit of knowledge on some of the electrical components that are going to be used for this project. Now you have a couple choices. Most of these relays and switches here can be purchased at your local auto parts store. You can get them online. It's a little bit cheaper in most cases, and the quality is just about the same, I would imagine. First relay we're going to go over this type right here. It's a standard 4-pin relay, and basically with this relay right here, if you look at the diagram, there's the solenoid with its contacts, and then you have the mechanical switch that's normally open, so it's not making contact when the solenoid isn't energized. So this one right here would be called a single throw. It's just a single throw with a single contact, and it's normally open. So that right here, we have it demonstrated in a little bit larger of a picture. This is our solenoid, our magnetic switch, and our contact. So basically what's happening here is when we energize the solenoid, say with the switch here, when we energize it, this magnetic leg would make contact 30 to 87, and power that's coming in here would be transferred in here, and then say go to whatever you're trying to power up. First, you're going to need a couple things. You're going to need some wiring. I mean, if you guys don't have all these nice connectors here, you can just kind of do it like this. I just have these wires, just the insulation torn off the ends, and then just push through the openings and the terminals there. You can do it. There's nothing wrong with that for testing purposes. You just got to be careful. These are positive or hots, and this is a ground, so if it does make contact, it'll create a direct short, and if your system isn't fuse protected, you could damage the relay, the wiring, melt a light bulb, damage your battery. All sorts of bad things can happen. So you want to make sure your power source is always fuse protected, and as you can see here, I have a 15 amp fuse on the power side that's protecting my electrical circuit. Let's just go ahead and start with the mechanical switch side and its contacts. So basically how this works here is you want power coming in to go to the mechanical switch. So power in, 12 volts, it's positive. So you got a power wire, and this right here would be fused. So if we went ahead and looked at the wiring schematic, got power coming in from the battery. Looks like it goes through part of the starter motor. Comes out this circuit breaker wiring. Okay, goes into the main ignition switch. Alright, feeds out to this red black. Comes right here. Goes down into this 15 amp fuse, inline fuse. Turns from a red black into a blue. Also splits off here, it looks like, to power your tail light when you turn on the ignition. And to also turn on your, let's see, looks like your position, your right, so it looks like your left and right hand position lights. Basically, it goes right down into the headlight dimmer switch. So that's basically that blue wire, that positive, 12 volt positive coming into the dimmer switch. That would be the 12 volts that you want coming into your relay here to terminal 30. That's going to be your power coming in. So we're going to go ahead and assume this is our battery on our Harley. Fuse, 15 amp coming in. Don't worry about how it's split off here. I'll get to that in a second. But you want to look at the back of your relay and identify the numbers on the terminals. This one right here, number 30. So go ahead and plug it in. Now that we have the relay plugged in, let's go ahead and look at the wiring diagram. So we have the blue coming in to the relay. So we're basically replacing this switch here with the relay, if that makes sense. So let's just say, and I'll get to this here in a moment, but the reason why we're not using this relay, I'm just showing you guys how it works, is because it only has one contact. So you have to choose in this situation, well, do I want a low beam or a high beam? You can only have one or the other with this type of relay. So for testing purposes, we're just going to go ahead and try the low beam. This yellow wire here goes to your headlight. It's the low beam power for your headlight. So basically, if we come over here and take a look at our headlight, our yellow wire, it's our low beam. It's coming out, and that's right here. So basically what we want to do, what the switch is doing in the factory switch, is basically it's taking this power right here and it's connecting it to the low beam using a switch. Now we're going to go ahead and use a relay since we don't actually have the switch. We're using a switch, we're relocating it. So basically we want to look at it as power is going from 30 to 87. So go ahead and connect your headlight. Let's go ahead and draw us a little headlight. It's going to be positive, 12 volts positive. You're going to see 85, 86, and then 87. Also says 87A underneath of it. That's fine. Go ahead and plug this into the 87. Alright, boom. Alright. In reality here, we've just wired up the positive circuit for our light bulb. We got power coming in through the fuse, going to our relay, and coming out, going to the headlight. The reason why the headlight's not on right now is because this is a normally open relay. The circuit is open right now. There's 3 terminals, 1, 2, and 3. Alright, now after a little bit of fine tuning and mess around and taking a look at the coils, you can see there's a lower coil and an upper coil. I believe the coil with the shield around it there, the deflector, that's your low beam, and then your high beam is the coil underneath of it. So by testing and moving the wires around on the terminals, you really can't do any damage unless you touch the wires together while they're connected on the same terminal. But if you just switch them all around, you really can't cause any damage and you should be able to figure it out. But what I figured out is basically on these H4 light bulbs is the ground terminal is on the left here, the high beam terminal is on the top, and the low beam terminal is on the right. And connect your ground wire, this left terminal, make sure it's connected to the ground side there on your battery. So how do we get this switch here, this magnetic switch, to close and make full contact. Well, that's achieved by energizing this solenoid here, which will close the magnetic switch and make contact, which should energize our light bulb. But before we do that, we must know the correct switch to be used. And the correct switch to be used in this case is a single pole, single throw toggle switch like seen here. Basically how this switch works is when the switch is in one position, it is normally open, and when you flip it, it bridges the contacts and then it's closed. This is the type of switch that we would use to energize the solenoid inside of our relay. Go ahead and put one probe in one contact and the other probe inside the other, and then you can see there when the switch is in the down position, there's no continuity, so the switch is open. If we flip it up, we get continuity. You can hear it by the audible sound of my multimeter that, you know, the contacts are now bridged. How coil works is you're going to hook up a positive here and you're going to hook up a negative here. And without getting into electrical theory, this is ground. Without getting into electrical theory and how the solenoid works, there's basically just a coil inside, and that's what dissipates the energy. If you didn't have this coil inside, if it was just like a switch, positive, negative, you would be creating a direct short. But because we got positive energy going into this coil, it's dissipated as heat and being used to close the switch. It can be used, the opposite side can go to ground. That's how you would do that. Or you could actually wire other stuff into that relay to power it if you wanted to. But that's a little bit more complex and not really necessary for what we're trying to do here. So with that in mind, the 85 contact terminal, that's going to be our positive, and the 86, that's going to be going to ground. We need something to control this switch, or to control this solenoid. And we're going to do that by using a switch right here. We're going to use a switch that normally, that's our battery. Switch that would, you know, basically open and close the circuit to energize the coil. And how I do that typically is solenoids, they don't really use a lot of power, so it's safe to do this on the same circuit. But basically, you have your power coming in for the battery through the fuse, and you can see here how I split it. One wire feeds the relay, and then I have another wire going into the switch. Okay, now this is a positive. These wires are connected. They're going to the positive circuit. So you got to think, we have positive energy right here at this switch. Okay, now when we close this switch, you know, flick it on, it basically makes contact between these two terminals, and now power goes through this wire, through the switch, and comes out through here. You got power waiting at the end here. You flip the switch off, there's no power here. And we can go ahead and check that. It's pretty simple. Let's go ahead and get your voltmeter, flip it on to volts DC current. Go ahead and get a good ground. Okay, so we got a good ground there, and then go ahead and get your positive lead. Go ahead and connect it. Sometimes my meter is a little funky, it reads, but right now it's off, should be reading 0, it'll calibrate right now. So go ahead and energize it. Boom. Well, my meter is a little off right now, it's showing way more than what it should. Hold on, let's see if it calibrates. So 0, about 14, 15 volts, that's not right, it should be like 13. Hold on. There it is. Okay, so now that shows us we're getting good power out of the switch. Shut the switch off, there's no power here. You flip the switch on, sending power through this wire, through the switch to right here. So what you're going to use this switch for essentially is to power this relay. You're going to send power to this relay. Okay, and then we're going to ground the back side, because we need to complete the circuit. Positive in, negative out, in order to complete the circuit, or this solenoid won't work here. So taking your negative wire, or whichever wire is in your circuit from the battery, negative wire, we're going to go ahead and connect that to the 86 here on the relay. Go ahead and connect that. Boom. And then we're going to go ahead and connect this. Make sure to shut off your switch. Okay, so we are fully connected right now. Relay's wired in, switch is wired in. Okay, no headlight. So, in theory, if I flip this switch now, power should energize the solenoid and close the switch, allowing power to come in through the relay from this 30 contact to 87 contact and flow out to my headlight. So let's see what happens. Boom. Look at that money. You like that? Alright, pretty simple. All we did is we took a single throw, normally open relay, and by diverting the power a little bit through a switch, we can safely turn on a light bulb without creating too much draw on the electrical circuit. So don't forget, that's why we use these relays. Okay, but the reason why, like I said earlier, we're not choosing to use this relay is, I don't know if you already could tell or if you started thinking about it, those who are, you know, maybe have a little bit of electrical experience. Well, how do we make the high beam turn on if we only have, you know, this one switch? And the way you do that is by using a different relay. So we're going to go ahead and show you right now the next relay that we have up in line here. So you're just running some LED lights, or you're running some fog lamps. This is the relay that you would want to use for that type of lighting system. These relays here are rated for, you know, 12 volts, 40 amps, typically up to about 180 watts. If you start exceeding that, then that's when you melt wiring, melt relays, and melt switches, possibly catch a bike on fire. So the next relay we're going to show you, we're not going to use this one for our headlight circuit, and I'll show you right now. But basically what they call this relay, this is a single throw, normally open, with 2 contacts. So it's the same thing like our last relay. Power comes in, but as you can see here, there's now, instead of 1 contact, there's 2. So what this one is used for is to power 2 lights, 2 circuits. Same setup, you're using a solenoid here. Power comes in, goes to ground, easy squeezy. So for this setup right here, we're going to show you how to wire up, say, dual headlights. Because, you know, some people want maybe dual headlights on their motorcycle or dual headlights on their buggy. Who knows? Locate terminal 30. That's going to be our power coming in. So 12 volt positive, power in. Alright, and we should already know from the last relay which one that is. That's power coming in through the battery, through right here. And if you guys can see, that's terminal 30. So go ahead and plug that bad boy in. Okay, so now that we have power going into our relay, okay, well, now we need to go ahead and wire up the 287s here, these 2 contacts, which will be going to our 2 light bulbs. Just imagine this is a light bulb, our little coil. These are both going to be 12 volts positive. We already have one wire hooked up to our headlight here, this yellow one. So we just want to go ahead and find this terminal and that terminal. So you can go ahead and choose any of them. We'll go ahead and go with the middle. Okay. Alright, so that's the positive on our left headlight, positive on our right headlight. Let's go ahead and connect this one. So we got one connected. Let's go ahead and connect the other 87. That's going to go right here, right to the side of this one. Okay, so boom. Power coming in. Power in. 12 volts. Positive. And you're going to be using the same power These are the same powers. They're the same. They're connected right there, if that makes sense. Splits off. Okay? And then this one right here would go to ground. Go through a switch, of course. That's our switch. And that's what's going to energize it. So we want our leg from the switch here to connect to the 85 on the relay. So go ahead and find 85. It's kind of hard to see, but it's 85 is right there. It's upside down. Go ahead and connect that. Boom. Alright, and the last but not least, your 86, that goes to ground. So ground right off the battery here. That's your 86. Go ahead and connect it. Hook up the ground there. Alright, and let's go ahead and just see if we have anything that's hot. Nothing. 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 Oh, okay. So that's our power. So that's good. Alright. So in theory, when we hit that switch, this should become energized, which closes the circuit and turns on both those headlights. Ready? Boom. Look at that. Alright, so we're using this relay here. By flicking this switch, we're sending power in through this solenoid, closes this mechanical switch to energize both these contacts, the power, both our headlights. That's how you do that properly without causing excessive load on the system. Right here would be more useful on light bulbs that have single coils, like a 55 watt or a 65 watt filament, and that's it, just a single filament. These dual filaments are used for high beam and low beam circuits. Okay guys, so this is the relay we're going to be using for our project right here. They all look like the rest. They're pretty much almost all the same. The only difference is this one has 4 pins and these two have 5, and they're all wired differently inside. I shouldn't say wired, but they're all designed differently inside in what they do. So this is the one we're going to be using for our electrical project. And you might say, well, why are we using this one? And the reason why we're going to use this one is because the type of relay, it's a double throw, single pole double throw. Power coming in through the 30 like we normally do, alright, but when this one right here, this switch, when it's in the closed position, normally closed, when the solenoid is not being energized, there is power always flowing from 30 to 87A. And that would be to power your low beams. If you energize this solenoid here, it would close the switch and energize 87, which would turn on your high beam. And the thing about that, what makes this switch cool is when you energize this solenoid, you're basically opening up this contact and energizing this contact, and vice versa, opening up this contact and energizing this contact. So this would be perfect for a headlight situation, because when you turn on the bike, you want the low beam to be on right when you turn it on, and when you hit that switch, you want the high beam to come on. And that's just how it needs to be. And for safety reasons, we're going to go with this relay setup because it always allows the low beam to be on and energized the second you turn on the key to the ignition. 12 volts coming in right here from the battery fuse to this number 30 leg. So let's go ahead and find 30. That's this terminal right here. Okay, let's see, power coming in through the battery, through the fuse, splits off, boom. Alright, got power going to 30. So now, alright, let's wire up the high beam and the low beam. So we got, alright, this one right here is a normally closed. So that means when the solenoid is not energized, alright, this is making contact. When in just its normal stationary position, 30 to 87 is bridged and connected, and power is flowing. So we want our low beam to be on, so we're going to go ahead and connect our low beam wire to 87A. And it's pretty simple. We're only going to use one light bulb for this test, not two, so we don't create too much of a draw. Grab your yellow and find 87A on your relay. That's going to be this middle contact right here. Typically the 87As are always in the middle, and you see that right there, boom, the light automatically came on without the solenoid even being hooked up. So hey, that's cool. That tells us that the relay's working, because power just went in and boom, there it is, the 87A. So go ahead and wire up the high beam off the light bulb. So that's going to be this red wire here on this top terminal coming in. Okay, and we basically want that to go to the 87 on the relay. Okay, so go ahead and find 87. That's going to be right here, this terminal right to the side of the low beam. Go ahead and plug that in. Alright, cool, nothing's happening. And it shouldn't be, because our battery's not grounded right now. Shouldn't be anything happening. Look at this solenoid and see how to wire that one up. Got power coming in through a switch. It's 12 volts positive. This one right here, 86, that's going to go to ground. Goes through the switch right here, then comes out, goes to 85. So find 85 on your relay. It's going to be this terminal right here. Boom, plug that in. And then now 86, that goes to ground. So you're ground off your battery here. Go ahead and take that. 86 is right here. Boom. Okay, so relay's hooked up, light bulbs are hooked up, switches hooked up. Okay, cool. Alright, so that shows us that the relay is working. The low beam circuit is being energized right now, because the relay is in the normally closed position. Now at the flip of a switch, we're going to flip this switch and allow power to go in from here through the switch to energize this relay. And what it's going to do is it's going to open up this circuit and it's going to close this circuit. Let's go ahead and watch. See that? See how the lower filament's energized right now? Now look, when I flip the switch, look what happens. The upper filament now becomes energized. We actually have our wires kind of switched around right now on the light bulb. Looks like these wires right here should actually be switched. This would be the low beam, that would be the high beam. But hey, it's working. That's basically how it works. Okay, so that's pretty much it. This is the relay that we're going to be using here. As you can see, it flicks does our low beam and our high beam no problem, and it doesn't really create too much drag on the system. We're going to go ahead and just for extras, we're going to go ahead and just show you guys another possible way to do this without actually using a relay. And this is pretty cool. You can use what's called a 3-pin 3-position toggle switch, and some people might want this over the relay. And the reason why is because it has a on, off, and on position. So what you can actually do is when the switch is in the middle position, it's actually open up the circuit and you won't have any headlight on even though your bike's running. And then you can go ahead and flip that to your low beam or flip that to your high beam. Now you're probably wondering, well, doesn't that mean it's going to shut off your light, say if you're in the low beam to the high beam? Yes, it will, and that's why I decided not to use this switch. But, you know, maybe some of those outlaw Harley guys, you know, this is a great option for them. Maybe they want to kill their headlights when they're running from the cops. Hey, I don't know. Basically, how this switch works, we can go ahead and test it with the multimeter before we start hooking up power to it. Put your meter in continuity mode. Alright, so it's in the off position, there's nothing. Flip it this way, nothing. Flip it the other way, we get continuity. Now let's go ahead and switch them, see what happens. So flip it this way, got continuity, nothing, nothing. Okay, so that's basically what a three-way switch is. So got basically power coming in to the middle terminal. We got, I mean, it doesn't really matter. It depends on how you put the switch in. But you can either have the low beam to the top or the low beam to the bottom, high beam to the top, low beam, high beam to the bottom, doesn't matter. Let's go ahead and flick it, see what happens. Alright, boom. We got the lower filament right now turned on. Let's go ahead and hit the switch, see what happens. Shuts it off. That's the mill position. Let's go up. Ooh, look at that. The upper filament's now energized. Flip the switch. No power to any. Lower filament. It's pretty cool. So, I mean, looking at that, I mean, with that in mind, you just got rid of like a bunch of wires by using this switch. You don't have to run a relay. You don't even really have to know much. It's pretty easy. It's a lot easier to hook up using this method, using the toggle switch, because it just has power coming in, then 2 powers coming out for your low beam and your high beam. Simple. You don't have to mess with a solenoid and the circuitry for that. Best way to do it on a Harley Davidson type electrical system, because they're not using relays for to energize the headlight system. They're using a dimmer switch or a drum switch. So if you can find this type of toggle switch at your local auto parts store, it'd be the best type. What Harley Davidson's using is a rocker type single pole double throw switch. As you can see here, there's 3 wires on the inside, and basically if we look at this picture here, you have power coming in, and then in one position the switch would be normally closed, and then if you were to flip it, it would go to the other position and this would be closed and that would be open. And that's basically all they're doing. So on the Ford controls, on the original Ford controls on a Harley, uses a rocker type. If you had the access to it, you would try to get a toggle type like so. We weren't able to find one, hence the reason why we're using a relay to operate our lighting circuit. On a Japanese motorcycle, most of them, like Yamahas, are using relays to energize the headlights, and the reason for that would be is because they typically have smaller batteries with less cranking amps, lower amp hour rating. So to have, you know, to run the bike, especially during starting on like a Japanese motorcycle, if you have the headlights on, it's going to cause a large draw on the starting system and possibly damage the battery or heat up electrical connections and wires and cause issues. So their engineers figured that. Harley Davidson, more of an archaic design, they're using really big batteries and circuit breakers and stuff like that. So they just have a lot of power coming in straight through the switch, through this little fuse here, right to the headlight, and they don't care if you're trying to start the bike or not. If the headlights on the low position or the high position, when you go to start the bike, it doesn't cut out that circuit. It still, you know, the headlight stays on when you're trying to start the bike, and that's because Harley Davidson's use a different type of starting circuit than Japanese motorcycles. It's a little bit more heavy duty, and you know that's because they're cranking over a big V-twin engine. You know, requires a lot more force to rotate that thing. So those are pretty much the different options. You know, if shoot, I mean, we could just keep on going on options, but those are the basic options for, you know, a do-it-yourself or something like really practical, like just putting lights on your Harley, or maybe you want to put some lights on your dune buggy or something, or you could even do this to put lights on your car. I hope I was able to help you guys and everything was clear and visually acceptable. I appreciate you guys watching, and like I said before, if you're not following, follow me now so you can go ahead and stay up to date with all my new videos I'm going to be posting. And if you appreciated this video, go ahead and give it a thumbs up, and stay tuned for the next one.